Hi, so this is an example of an empirical formula question. So this is from the textbook, question 44. I think it's in the chapter review. So the question, when 0.2 grams of white phosphorus is burnt in oxygen, 0.456 grams of an oxide of phosphorus is formed. Deduce the empirical formula of this oxide. Okay, so as we know, we need to set this up as a ratio. So we can use the two masses we have. So our phosphorus is 0.2 grams. Now our oxygen, now here's where we need to be a little bit careful. Our oxygen, it doesn't specifically tell us how much oxygen we have. However, we know that the oxygen and the phosphorus together will give us 0.456 grams of product. Now, of that, we know that 200 grams, 0.200 grams was phosphorus. Therefore, the rest must be oxygen. So we have 652. So 0.256 grams must be oxygen that the phosphorus is reacting with. Okay? So, from this, we've got 0.2 grams of phosphorus and 0.256 grams of oxygen. Okay, now we divide each of those by the relative atomic mass of the element involved. So, phosphorus has a relative atomic mass of 31. Oxygen has a relative atomic mass of 16. Okay, now if we do these calculations, if you put this into your calculator, on the left we will get 0.2 divided by 31 is 0.0065 with some other numbers, and on the right, 0.256 divided by 16, 0.016. Okay, now to find our empirical formula, we need to divide by the smallest number, which in this case is 0.0065. So we divide both sides by that. And again, if we put this into our calculator, we will get 1 to about 2.5, which is close enough in this case. So this is a 1 to 2.5 ratio. So for every one phosphorus atom, there are 2.5 oxygen atoms. Now, unfortunately, there's no such thing as 0.5 of an oxygen atom. So we need to scale this up to be whole numbers. So we need to multiply both sides by 2 just to get this into whole numbers. And this will give us 2 to 5. It's a 2 to 5 ratio. Therefore, the empirical formula of this is 2 phosphorus and 5 oxygens. Okay? P2O5.